Hello everyone. Today we are presenting on machine learning for natural language processing. My name is Mohsin Patel Syed and I am accompanied by Mohammed Vohra and Mohammed Imroze. So we are going to discuss what NLP is and how it's different from general machine learning, the ways we use it, and some of the latest advancement and challenges in the field of NLP. So what exactly is NLP? So I'd rather say it's more than just another AI model. NLP is a way for machines to understand human language. The ultimate goal of NLP is to bridge the communication gap between humans and machines. So yes, NLP aims to make computers understand us. Like computers usually understands the binary code. So they would be understanding us humans beyond a way that they understand binary code. They are going to understand human language. It's about making them understand languages that we speak, like English, Spanish, or Chinese, whatever. So a textbook definition for NLP would be it's a branch of artificial intelligence. It enables machines to understand, interpret, and respond to human language. For example, imagine that you got a tool that can read email, analyze the tone of the email, and reply appropriately to that email. Yes, that can be possible with the help of NLP. So that's one of the aspects of NLP that we call as text classification. In simple words, like in terms of email, think like classifying an email, either it's spam or not spam. So that's a component of text classification. It classifies whether an email is useful or not, like it contains any malicious files or something like that. If it contains something like that, then it is flagged as spam. So that's a aspect of natural language processing. There are many more components for that, like machine translation, sentiment analysis, including task classification. So machine translation, we have a classic feature called Google Translate, where we can translate anything on the tip of our fingers. And we can also use sentiment analysis. It is commonly used in the field of customer segmentation. Like suppose you are a big tech giant that has recently launched a product and want to know the reviews about the project, like what's the people's understanding of the product. So you go ahead and gather all the reviews and perform sentiment analysis to gather data and think what and to know what people are thinking about the project, like it's a positive review, negative, or what they have a neutral reaction to that. So that's all possible just because of NLP. So coming to our topic, machine learning and NLP. So there are lots of questions that arises. How does machine learning fit into NLP? Like what's the difference or what similarities between them? So just to make it clear, traditional NLP was a rule based, like it relied on coded rules for language processing. A classic example I could use for this is spacey. Like I don't know, many of you have heard about it. Like if you know, like there was a tool called spacey that was a rule based code, but now we've got a lot of latest technologies that use machine learning. So the integration of machine learning is very much useful in NLP because model learns from data, which is especially useful in complex tasks. Now we have a very good example for this as well, what we use as ChatGPT or BERT as well. So they use machine learning to recognize and generate human-like responses to patterns and questions, whatever we ask them. Anything we throw at them, like they have a response at the tip of the hand. So that's because of machine learning. Even chatbots. Chatbots use machine learning to understand and answer queries. And how's that possible? And how's that like how can a chatbot answer like humans? It's because of machine learning, because they learn from thousands of examples and get better over time. So again, to get into this, what is machine learning? Again, machine learning is a part of artificial intelligence where model learns from data. Like we feed data to the model, so it keeps on training on that data, and then it gathers and it learns a pattern or algorithm. Then it shows solutions to us. So in terms of NLP, like they identify patterns and relationships, which is useful for language-based task in NLP. You know, for example, just take a customer review segmentation, like customer reviews. ML model can identify whether a review is positive or negative, what are the sentiments in the reviews, and it can identify sentiments on new reviews. Like if you feed a data that contains positive and negative reviews, and you just test it on an unseen data, unseen reviews, the machine learning model can understand what are the reviews and what is the customer's demand. So that's what machine learning does when it's combined with NLP. So again, there are three types of machine learning. We'll just have an overview of that. Like it's supervised machine learning, unsupervised, and reinforcement learning. So supervised learning would be like learning from labeled data. Like you'd have a data that's like, for example, again, in case of what sentimental analysis, you'll have positive reviews and negative reviews, or in some cases, neutral reviews as well. So you have a labeled data, and the model learns from it. And when an unseen data is given to it for prediction, it predicts whether it's positive, negative, or neutral. In case of unsupervised learning is used to find hidden patterns inside of data. What it does, it clusters articles on similar topics without labels. Like whatever similar topics it gathers, it just clusters them and uses its patterns technique to identify whether it's positive, negative, or neutral. Whereas in case of reinforcement learning, it learns from trial and error phase. Like it tests a data, tries it, and if it's wrong, it just flags it towards another one and keeps on testing until it gets right. So that's what reinforcement learning is. It's like playing a game with AIs. So now heading forward, how does machine learning help in NLP? For starters, there are many ways. Like we'll cover a few of them. Some of them being text processing and language translation, speech and conversational system, information extraction and summarization. To start with text processing, it helps break down and clean text for analysis. Like text processing is like it breaks down all the data and helps us to like many of us know now like how we break down sentences into stop words and then stop words removal of all the words and convert them into tokens. That's all possible because of machine learning nowadays. And while classification organizes all these data, machine learning improves translation accuracy. For example, just I got this very good example that we use in our daily life. Like everyone uses Siri nowadays. Like Siri uses machine learning in speech recognition and response generation. Like whatever we speak, Siri gathers all that data and provides an accurate response because of machine learning. So when we come to text processing is like categorizing content into classes. Example like spam or not spam. Like it categorizes whatever the data is, like it's a spam email or a not spam. And it's very much common in email filtering, topic retention, sentiment analysis. Sentiment analysis is a classic example whether it's positive or negative. When we come to machine translation, like again very good example I get is Google Translation. So that translates from one language to another with Google Translate as a classic example. Like it uses machine learning like any other language. You haven't heard of Chinese, you don't know any basic phonetics of Chinese, but still you can able to translate and learn about it. That's because of machine translation, and the machine is able to do it because of the integration of machine learning and natural language processing. And sentiment analysis, it identifies emotions in text. Like a machine cannot identify emotions. It doesn't know what is the context behind a word. But with the help of machine learning, with the help of natural language processing, now we can perform sentiment analysis, and machine is actually able to understand the context behind the words, and what we call it as sentiment analysis. So let's head forward. And the next is conversational and interactive applications. Conversational interactive applications, a classic example of chatbots and virtual assistant. Like we have everything in nowadays, like Siri, Alexa, Google Home, everything. Like they understand what we speak. So these answer question and assist us with tasks. you know it makes life very much easier. That's all because of natural language processing and machine learning. And again, when we head towards speech recognition, what basically it does is convert speaking of words into text, and then those texts are performed as tasks. Like for example, when I come in and I say, "Hey Siri, play a song," it breaks down those words into text, and that text is in turn converted into a command, like a task. So it's widely used in accessibility tools, and it's common in virtual assistants. So they recognize speech, they recognize text. That's all because they contains a large corpus of data, and that data in turns help us simplify and helps us in doing our daily life tasks. Yeah, so advanced information processing application is one of the most important, and I think it's very much important. Like it can, because I think everyone is aware of named entity recognition. This is one of the important aspect where it extracts names, dates, location, text useful in search engines. NER is useful in every domain in nowadays. Like especially in healthcare. It's used for like summarizing text classification of patient history, the electrocardiograms, and all of their important medical health data. Everything is in place because of named entity recognition. Also, it's useful in search engines and document processing. Like on web, we have like huge loads of documents, and everything is organized because of named entity recognition. Next is text summarization. Text summarization condenses large texts for quick reading. Like, um, for example, take an example of big news houses, like where they publish huge loads of huge paragraphs of data. So what text summarization does is like they summarize all of those texts, all of that news into small and crispy paragraphs, and we have it on our mobile apps, all those news apps that we use. That's because of text summarization. When coming forward, that's question answering system. Like again, question answering system is what I get is chatbots and FAQ bots. Like they understand our questions, and they understand and they provide a valuable and valuable feedbacks or whatever answers that we are looking for. That's because of question answering system. And all of these are just because of NLP and machine learning. Like these are the applications of machine learning, all of this text pre-processing system applications and conversational interactive application and advanced information system. All of these are working well and working handy just because of integration of machine learning and natural language processing.
Hello everyone. I'll be discussing some of the key challenges and recent advancement in natural language processing. Uh, there are basically I'll be discussing four major challenges. AI is transforming industries and shaping the way we interact with technology, but as it comes more integrated into our lives, it also brings a set of challenges that we can't ignore. In this presentation, I'll go over some of these major challenges and the exciting advancements that are helping us address them. So coming to the challenges, first I will be discussing about data and model challenges, in which it is one of the biggest challenge in AI that involves data and models we use. High quality data is essential for training effective models, but such data is often hard to find. It can be sparse or biased. These bias these biases in the training data get picked up by machine learning models, which can lead to unfair or inaccurate outcomes. For example, a model trained mainly on Western data might not perform well when exposed to other cultural contexts. There's also the issue of interpretability. Many models perform well on training data but struggle to generalize across different domains or contexts. In addition, large language models, LLMs, and deep learning systems often operate as black boxes, meaning it's difficult to understand exactly how they reach certain conclusions. These lack of transparency poses a challenge, especially in critical fields like healthcare, where knowing why a model makes a decision is crucial. And the second challenge is resource and language barrier. It's another major challenge related to resources and language diversity. Training and deploying large AI models is computationally intensive and costly. For example, it takes significant processing power to train state of the art models, making it expensive and in some cases environmentally unsustainable. Privacy is also a pressing issue. Since AI models often handle sensitive data, balancing accuracy with user privacy is an ongoing challenge, particularly in applications that deal with personal information. Then there is the issue of language representation. Most models are focused on English, leaving other languages underrepresented. These means AI might not work as well as for non-English speakers, which is a huge limitation. Even when models are adapted to other languages, they often miss cultural, which impacts their accuracy and reliability. These were the challenges. Uh, Now I'll be discussing few advancements in NLP, like large language models and hybrid approaches, speech recognition, machine translation, named entity recognition. So, despite these challenges, there have been major advancements thanks to progress in machine learning and AI. Here are some of the recent records, though making a big difference. First, coming to large language models. Large language models or LLMs have made a huge impact. Models like GPT-4 by OpenAI and Llama 3.2 by Meta AI have been trained on extensive datasets and contain up to 405 billion parameters. These large scale allows them to generate human like responses and power virtual assistants on platforms like Facebook, Instagram, and WhatsApp. These models can handle everything from summarizing text to creating responses, which makes them versatile tools for a variety of applications. Coming to machine translation is another area that has seen remarkable progress. In the past, translation models often relied on English as an intermediary, which introduced errors and lost meanings. Now, models like Facebook M2M100 can translate directly between languages without these intermediary step. This allows for more accurate and culturally relevant translations. Neural machine translation used by Google improves fluency and coherence by applying deep learning techniques to capture the context of sentences, creating translations that are closer to native speaker quality. Coming to the third one is hybrid approaches. Hybrid approaches combine machine learning with rule-based methods. These integration of the statistical models with explicit rules helps enhance AI's reasoning capabilities and pattern recognition. Hybrid models can be especially useful in fields like legal document analysis, where certain languages needs to be interpreted based on context, but also follow specific rules. By combining these approaches, models can achieve a more balanced understanding. Named entity recognition has advanced significantly with the development of models tailored to specific fields like healthcare or finance. By training models to recognize industry specific terms and entities, we can improve their accuracy. For example, a healthcare focused NER model can more accurately identify terms related to drugs or medical conditions, which is invaluable in fields that rely on precise terminology. And the final one is progress in speech recognition. Lastly, we have made strides in speech recognition. Traditionally, converting audio to text required multiple processing steps, which could introduce errors. Models like Mozilla's Deep Speech simplify these processes by using an end-to-end approach that directly converts audio into text, reducing potential points of failure. Additionally, Facebook's Wave 2VEC 2.0 uses large amount of unlabeled audio to improve its accuracy, making it more effective at understanding different accents and dialects.
So we got applications of NLP. Does NLP has any use in world task or any domain? And the answer is yes, of course. NLP is just useful in almost every domain and provides a key range of application in healthcare. We got finance, we got customer service, we got education, etc. So mainly, if we talk about healthcare, I think that's like a pivot point in terms of application. If you see like healthcare, we got the media text medical text analysis. That's like a really good thing because it involves like machine learning to extract, interpret, and manage information on structured medical text and like clinical law, research papers, electronic health records, and everything. Like clinical documentation is one of the things that gives us like a pivotal edge. Like NLP systems can automatically transcribe or summarize doctor-patient interaction, diagnosis, and treatment plans. They also have a standardized terminology, allowing consistent and searchable records. Okay, and then we got finance. We got in finance, the main thing would be fraud detection. The fraud detection we can say is like the case of people using fake like credit cards and frauds, credit card frauds, and all kind of frauds. It helps the language like an NLP model can scan text data for you unusual patterns, potentially indicating fraud. Okay, and then we got the customer service, like all kinds of chatbots. Okay, chatbots for interaction, sentiment analysis, like taking feedbacks from customers and improving their system. Then we got education. Education is like LLMs, automatic grading, content summarization. So in education, I would say like a personalized learning would be an important thing too, like adopting learning platforms recommend educational resources based on school student progress. Okay, so we got various case study on this machine learning on NLP. One of those would be Google Translate and language barrier in global communication. So that would be like Google Translate, like you're using neural machine translation that translates over 100 languages with high accuracy. People can understand foreign languages real time, breaking down communication barrier. And we could use it as a I think in today's times, the most important would be case study of a chat GPT, like, OpenUI and then ChatGPT and all kind of chatbot that are available right now that use AI to give like smart and human-like conversation across various domains. Like these are like trained models. They take text and generate a coherent, relevant response based on context. Impact, like it enhances users' experience by stimulating new natural conversation, education, entertainment, business. It automates tasks, minimizes human error in routine documentation. So, finally, I would say like potential and opportunities. It has like a vast kind of potential, like unstoppable, and like opportunities that will like continue to grow. It's not gonna stop. It just goes. It's just going to keep on growing. Like expanding multilingual and cross-cultural, like developing models for unrepresentative classes. Like because mostly NLP is based on English and major languages, while disregarding like most of the languages like we could never like have even imagined, but we are like developing models for that, for those things. Those not languages would be a good thing, like virtual assistants, social media apps, customer service in diverse languages. Then we got human AI collaboration, we got ethnic responsible AI, like transparent NLP models to build trust in field like law and healthcare. And I think the future directions would be to have enhanced model efficiency, scalability, contextual understanding. Then we got ethical NLP and bias reduction. We got personalized and adaptive NLP models. We got multi-model integration. I think future direction would be more. I would say is like like it's the ability to keep on growing. And believe me, this thing is not gonna stop, like because these like the integration of machine learning and NLP across healthcare, finance, customer and education is already reshaping these industries by automatic tasks, enhancing personalization, providing real-time insights and everything. As research advances, especially in areas like ethical AI and multilingual processing, the potential of NLP is to drive further innovation and create lasting impact will only grow. Now is the pivotal time for education to invest in and explore these technologies, stay ahead of the curve, and setting the stage for a more intelligent, responsive, and connected future. Thank you.